In this example, we need to change the following from exponential form to logarithmic form. And I have 4 expressions here. So quickly to review, the functions f of x equals log to the base b of x and g of x equals b raised to the x power are inverses. So b raised to the y equals x is equivalent to y equals log to the base b of x. So here we have our exponential form, and here we have the logarithmic form. So in these expressions, I'm given the exponential form and have to convert it to the logarithmic form. Please remember, in all these problems, the base of the exponent is always equal to the base of the logarithm. And when I do my conversions, I'm going to say log to the base b of x equals y. Log to the base b of x equals y. Because remember, the log y always comes from the exponent. So looking at my first example, b cubed equals 343. The base is b of my exponent, so I'm going to have log to the base b of 343 equals the exponent 3. So that is my logarithmic form. Next example, 4 raised to the negative 3 equals 1 over 64. Who's the base of my exponent? 4. So that's going to be the base of my log. So I'm going to have log to the base 4 of 1/64 equals the exponent negative 3. Next example, e raised to the w equals 3. Who's the base of my exponent? E. So that's going to be the base of my log. So I'm going to have log to the base e of 3 equals the exponent w. But do we ever write log to the base e of anything? No, that is the natural logarithm. If the base is e, it's the natural logarithm, which we just write as ln of 3 equals w. So we would read this, the natural log of 3 equals w, and that is the logarithmic form. And in the last example, we have 10 raised to the half equals x. Who's the base of the exponent? 10. So that's going to be the base of my log. So I'm going to have log to the base 10 of x equals my exponent of 1/2. But do we ever write log to the base 10? No, that is the common logarithm. And we just write that as log with no base of x equals 1/2. So if there's no base written, we know it's a 10, and we read this, the common log of x equals 1/2. Now we've got very good at converting from exponential form to logarithmic form. Now we need to learn to go in reverse. So on these examples, we need to change the following from logarithmic form to exponential form. First example, log to the base b of 100 equals 2. So remember, the base of the log is going to be the base of the exponent. b raised to the second power equals 100. Because remember, the log is the exponent I raise b to get 100. So this is the exponential form. Next example, log to the base 8 of 2 equals 1/3. Who's the base of the log? 8. Who's going to be the base of my exponent? 8. So I'm going to have 8 raised to the 1/3 power equals 2. When you're finished doing these, always check that the log becomes the exponent in exponential form. The next one, the natural log of x equals 5. There's no base written here, but remember, what does this mean? This means log to the base e of x equals 5. So e is the base of the natural log, so e is going to be the base of my exponent. E raised to the 5 equals x. And our last example, the common log of 49 equals z. Who's the base of the common log? It's a 10. So 10 is going to be the base of my exponent. So I'm going to have 10 raised to the z equals 49.